On the night of August 15th, 1977, a man named Jerry Ehman sat down at a table with a stack of computer printouts. He was a volunteer, an astronomer who gave his time to a project that most of the scientific establishment considered a long shot at best and an embarrassment at worst. The project was called SETI, the search for extraterrestrial intelligence, and its goal was exactly what it sounds like: to scan the sky with radio telescopes and listen, to sift through the noise of the cosmos and look for something that did not belong, something structured, something intentional, something that could only have been made by a mind. Most nights, there was nothing. That was expected. Space is vast beyond any human intuition, and the odds of pointing a telescope at the right patch of sky at the right moment to catch a signal from a civilization that may or may not exist, orbiting a star we may or may not have cataloged, transmitting on a frequency we may or may not be monitoring. Those odds are, by any reasonable calculation, extraordinarily small. Most nights, the printouts showed what they always showed: the background hiss of the universe, thermal noise, interference, the electromagnetic equivalent of static, numbers and letters that hovered in a predictable, unremarkable range that told you nothing except that the cosmos was, as usual, not talking. Jerry Ehman knew what the numbers were supposed to look like. He had been doing this long enough to read the data the way a musician reads sheet music, fluently, automatically, without having to stop and think about each symbol. A trained eye moving down columns of alphanumeric characters, each one representing the intensity of a radio signal detected at a specific frequency during a specific window of time. The numbers rarely rose above a 1 or a 2, sometimes a 3. On exceptional nights, perhaps a 4, nothing that warranted a second look. He was working through the printout from the Big Ear Telescope, a radio observatory at Ohio State University that had been scanning the sky as part of the SETI program since 1973. The printout in front of him represented data collected several days earlier on the night of August 15th. The telescope did not have the ability to alert anyone in real time. It simply collected, recorded, and printed. And then a human being sat down and read what it had found. Eamon was partway through the printout when his eyes landed on something that did not belong: a sequence of characters in one of the columns, 6EQUJ5. He stared at it. In the language of the data printout, each character represented a signal intensity. Numbers from 1 to 9 indicated intensities from 1 to 9 times above the background noise level. When the intensity exceeded 9, the system switched to letters. A represented 10, B represented 11, and so on through the alphabet. The highest intensity Jerry Ehman had ever seen in that data, the highest intensity the Big Ear had ever recorded in years of continuous observation. The kind of reading that the system had never produced before in any of the thousands of hours of sky it had surveyed. A signal intensity of 30 times above the background noise. 30 times louder than everything else the universe was producing at that moment. And it had not simply spiked and vanished, it had risen, peaked, and fallen again. Exactly as you would expect a signal to behave if it came from a fixed point in the sky as the rotating Earth carried the telescope's field of view across it. A smooth, natural bell curve of intensity, rising from nothing, climbing to that extraordinary peak, fading back into silence in exactly 72 seconds. 72 seconds. Jerry Ehman picked up his red pen. He drew a circle around the sequence 6EQUJ5. And in the margin of the printout, in ordinary handwriting, he wrote a single word. Wow. He did not call a press conference. He did not alert the media. He did not make any announcement at all. He was a careful scientist, and a careful scientist does not announce the discovery of extraterrestrial intelligence based on a single data point from a single night. He flagged it. He noted it. He made sure it was recorded and preserved. And then he waited for it to happen again. It never did. That circled printout, that single sheet of paper with one word written in red pen in the margin, became one of the most examined, most debated, most haunting documents in the history of science. It has been studied by astronomers and physicists and SETI researchers for nearly half a century. It has been the subject of papers, conferences, documentaries, and books, and to this day, nobody has been able to explain with certainty what produced it. Not a satellite, not a comet, not interference from Earth, not a malfunction in the equipment. Nobody knows. If you are the kind of person who finds that thought uncomfortable, the idea that something spoke once from the direction of a distant constellation and has never spoken again, then this documentary is going to stay with you. And if you want to keep exploring these questions, subscribing to The Cosmic Depth takes 2 seconds. We post new documentaries every few days, every one of them going somewhere most channels never think to look. Because the wow-wow signal is not just a data anomaly from 1977, it is a mirror. A question that has been sitting unanswered for 45 years, reflecting something back at anyone who looks directly at it. What are we willing to believe? What are we afraid to believe? And what does it mean that the universe spoke once, just once, and then went completely, utterly, inexplicably silent? For 4 years before Jerry Ehman circled that sequence of characters, the Big Ear telescope had been doing something that no instrument in human history had ever done before at that scale. It had been listening, not to music, not to weather, not to the communications of other human beings bouncing signals off satellites and back down to Earth. It had been listening to the universe itself, scanning the sky frequency by frequency, patch by patch, building up a picture of the electromagnetic noise that fills the space between the stars. To understand why the wow signal was so striking, you first need to understand what the big ear was, what SETI was trying to do, and why the scientific establishment of the 1970s regarded the entire enterprise with barely concealed skepticism. The idea that we might detect an extraterrestrial civilization by radio was not new in 1977. It had been around since 1959 when two physicists named Giuseppe Cocconi and Philip Morrison published a paper in the journal Nature that quietly changed the direction of astronomy. Their argument was elegant and simple. If there are other civilizations in the galaxy, and the sheer number of stars made it statistically difficult to argue there were not, then at some point, some of them would have developed radio technology. Radio waves travel at the speed of light. They can cross interstellar distances. They pass through the gas and dust that fills the space between stars without being scattered or absorbed. They are, in that sense, the most practical way to send a message across the galaxy. Cocconi and Morrison asked a question that sounds almost naive until you think about it carefully. If another civilization wanted to announce its existence to the rest of the galaxy, if it wanted to say, "We are here, we exist, we are listening," what frequency would it use? The answer they proposed has held up for more than 60 years, 1,420 megahertz. That specific frequency corresponds to the natural emission of hydrogen, the most abundant element in the universe. Every hydrogen atom in existence, whether it is floating in the space between galaxies or locked inside a star, emits radiation at 1,420 megahertz. Any civilization that had developed radio astronomy would know this frequency. Any civilization that had studied the cosmos would have detected it. It is, in a sense, the universal constant of radio astronomy, the one frequency that any intelligent species anywhere in the galaxy would almost certainly know about. Cocconi and Morrison argued that 1,420 megahertz was therefore the most logical frequency to use for interstellar communication. It was the cosmic common ground, the frequency that required no shared language or prior agreement to find. Any civilization advanced enough to transmit and any civilization advanced enough to receive would both know to look there. Their paper ended with a sentence that has echoed through the SETI community ever since. The probability of success is difficult to estimate, but if we never search, the chance of success is zero. That sentence planted a seed. A year later, in 1960, an American astronomer named Frank Drake pointed a radio telescope at two nearby sun-like stars and listened at 1,420 megahertz for 6 hours a day for 4 months. He found nothing, but the act of looking, the simple, committed, methodical act of pointing a telescope at the sky and listening, established something important. It established that this was a legitimate scientific endeavor, that it could be done, that it was worth doing. Drake went on to formulate what became known as the Drake equation. a framework for estimating the number of communicating civilizations that might exist in the Milky Way at any given time. The equation did not produce a definitive answer. It was never meant to. What it produced was a structured way of thinking about the problem, a way of identifying which variables mattered and which questions science needed to answer before the estimate could be refined. How many stars form in the galaxy each year? What fraction of those stars have planets? What fraction of those planets could support life? What fraction of those actually develop life? What fraction of life develops intelligence? What fraction of intelligent species develop radio technology? And how long those civilizations survive before they go silent? That last variable, the lifetime of a communicating civilization, is the one that keeps SETI researchers awake at night. Because if civilizations tend to destroy themselves shortly after developing the technology to communicate, the galaxy might be full of the ruins of intelligence rather than intelligence itself. The silence might not mean absence, it might mean aftermath. But in 1973, the astronomers at Ohio State University were not yet weighted down by those darker interpretations. They were in the early, optimistic phase of SETI, the phase where the universe seemed vast and full of possibility, and the only thing required was patience and a good enough instrument. The big ear was their instrument. It was not a dish telescope in the conventional sense. It was a flat reflector, a large fixed antenna lying on the ground like a metal field, designed to pick up radio waves from a wide swath of sky as the Earth rotated beneath it. It could not be steered or pointed. It simply listened to whatever portion of sky happened to be rotating into its field of view at any given moment. This meant that any given point in the sky passed through the big ear's beam for exactly 72 seconds as the Earth rotated. Exactly 72 seconds. The same duration as the wow signal. This was not a coincidence. It was the first piece of evidence, before anyone had even analyzed the frequency or the intensity, that whatever the big ear detected on August 15th had come from a fixed point in the sky, not from a satellite in orbit, which would have moved, not from an aircraft, which would have passed through the beam at a different rate, from something stationary relative to the stars, something that stayed in one place while the Earth turned beneath it and carried the telescope's ear across it for exactly the 72 seconds the geometry allowed. Something out there. The big ear had been scanning since 1973. It had logged millions of seconds of data. It had detected thousands of signals, cataloged them, printed them, handed them to volunteers like Jerry Ehman to review. In 4 years of continuous observation, it had found background noise, interference, natural radio sources, pulsars, quasars, the faint glow of distant galaxies. It had found nothing that looked like the wee-ow signal. Not once. Not even close. Until August 15th, 1977. And the thing that makes that night so difficult to simply file away and forget is not just the intensity of the signal. It is not just the duration, it is not just the frequency, though but we'll come to that shortly, because the frequency is perhaps the most unsettling detail of all. It is the combination. Every single characteristic of the Wiao signal, the frequency, the intensity, the duration, the way it rose and fell, matched the theoretical profile of what a deliberately transmitted interstellar signal would look like if it were aimed at Earth from somewhere in the direction of the constellation Sagittarius. Not some of the characteristics, all of them. The Big Ear had been built to find exactly this kind of signal. It had been scanning for 4 years. And on one night in August 1977, for 72 seconds, something that matched every criterion perfectly appeared in its data and was never seen again. The sequence of characters that Jerry Ehman circled in red pen was not random. It was a code, not a code in the sense of an encrypted message, not something that contained words or mathematics or a greeting from another world. A code in the sense that it was a precise, quantified record of what the Big Ear's instruments had measured during those 72 seconds. A snapshot, a fingerprint, a numerical portrait of something that passed through the telescope's field of view on a warm August night in Ohio and left behind 6 characters on a sheet of paper. Those 6 characters tell a complete story if you know how to read them. The Big Ear's computer system recorded signal intensity using a simple alphanumeric scale. Each character represented the average intensity of the signal during a specific 2-second window. The scale ran from 1 at the bottom, barely distinguishable from background noise, through 9, and then continued into letters for anything stronger. A equaled 10 times background, B equaled 11, and so on through the alphabet. Now, read the sequence again with that in mind. 6 E Q U J 5. The signal began at an intensity of 6, quiet but already notable, already 6 times stronger than the ambient noise of the universe at that frequency. Then it climbed. E, 14 times background. Q, 26 times. U, the peak, 30 times above background noise. Then back down. J, 19 times. 5, back near where it started. A perfect arc. A clean rise and fall like a wave. This shape, this smooth bell curve of intensity, is precisely what you would expect if a powerful signal source were fixed in space and the rotating Earth were carrying a radio telescope's narrow beam across it. The beam catches the edge of the signal, picks up more and more of it as it moves toward the center, reaches maximum intensity at the midpoint, then loses it again as the beam rotates away. It is called a Gaussian profile, and it is the calling card of a point source, something located at a single fixed position in the sky. The WOW signal had a perfect Gaussian profile, not approximately Gaussian, not roughly Gaussian in the way that many natural radio sources are, a textbook Gaussian, as clean and precise as if someone had drawn it on a whiteboard, to illustrate what an ideal interstellar signal detection would look like. And then there is the frequency. The big ear was listening at 1,420 megahertz, the hydrogen line. The frequency that Cocconi and Morrison had identified in 1959 as the most logical channel for interstellar communication. The frequency that any radio-capable civilization in the galaxy would know. The frequency that requires no prior agreement, no shared language, no cultural common ground to find, because it is written into the physics of the most abundant element in the universe. The WOW signal was detected at 1,420.4556 megahertz, 4/10 of a megahertz above the hydrogen line. This small offset, this tiny shift from the center frequency is itself meaningful. Interstellar signals are expected to show a slight frequency drift caused by the relative motion of the source and the receiver. The Earth is moving. Whatever was transmitting would also be moving if it were on a planet orbiting a star. The Doppler effect, the same phenomenon that changes the pitch of a passing siren, would shift the frequency slightly from its origin point. The amount of frequency shift observed in the WOW signal was consistent with a source located somewhere beyond the solar system. Not consistent with a terrestrial source. Not consistent with a satellite in low Earth orbit or a transmitter on the ground. Consistent with something far away, in deep space, moving relative to the Earth at a rate that physics would predict for an object in another star system. Every number pointed in the same direction. Now consider the bandwidth of the signal. Radio signals occupy a certain width of the frequency spectrum, a range of frequencies across which they spread. Natural radio sources tend to be broadband. They emit across a wide range of frequencies simultaneously. Pulsars, quasars, interstellar gas clouds. They all spread their energy across the spectrum in ways that reflect the physical processes generating them. Artificial signals, signals designed to be detected, are different. A transmitter built for communication focuses its energy into as narrow a frequency band as possible. The narrower the bandwidth, the more of the total transmitted power concentrates at a single frequency, and the further the signal can travel before it becomes too faint to detect. The WOW signal was narrowband, exceptionally narrowband, so narrow that the big ear's receiver could not determine its precise width, only that it was smaller than the instrument's resolution could measure, which meant it was at most a few kilohertz wide, possibly much narrower. No known natural astrophysical process produces a signal that narrow at that frequency. None. This is the detail that separates the WOW signal from every other radio detection that SETI researchers have ever had to evaluate. Natural sources can be bright. Natural sources can appear briefly. Natural sources can even show up near the hydrogen line. But no known natural source produces a signal that is simultaneously bright, brief, at the hydrogen line frequency, moving at the right Doppler velocity for a deep space origin, showing a perfect Gaussian profile, and narrowband beyond the resolution of the instrument detecting it. All of those characteristics appearing together at the same moment in the same 72 seconds. The probability of that occurring by natural coincidence is, by any serious calculation, extraordinarily small. Ehman himself, years later, reflected on what he had found with a careful precision that only made the mystery more acute. He said that the signal was the most significant finding of the entire SETI program, that it matched the expected signature of an extraterrestrial transmission more closely than anything else ever detected. That if he had been asked before that night to describe what a genuine alien signal would look like in the data, he would have described something very close to what appeared on that printout. And yet, he also said something else, something that speaks to the honesty of a scientist who has spent decades sitting with an uncomfortable uncertainty. He said he did not know what it was. Not that it was extraterrestrial, not that it was natural, not that it was interference or a mistake. He said he did not know, and that after nearly 50 years of analysis and debate and follow-up observation, that answer had not substantially changed. The numbers are what they are. The profile is what it is. The frequency is what it is. The bandwidth is what it is. 6 characters on a printout, circled in red, with one word written beside them, and everything. Those 6 characters imply everything the physics of that signal suggests about its origin remains to this day without a definitive explanation. The data does not lie, but the data alone cannot tell us what spoke. There is a frequency that belongs to everyone, not to any nation, not to any scientific institution, not to any civilization on Earth. It belongs to the universe itself, written into the structure of matter at the most fundamental level, present in every corner of the cosmos, detectable by any species anywhere that has ever pointed an instrument at the sky and asked what the darkness is made of. It is the frequency at which hydrogen sings. Hydrogen is the oldest element. It was forged in the first few minutes after the Big Bang, when the universe was still a fireball of unimaginable density and heat, and the conditions existed, briefly, for only a handful of minutes, for protons and neutrons to fuse into the lightest atomic nuclei. Before galaxies, before stars, before any of the heavier elements that make up planets and oceans and living things. Before any of that existed, there was hydrogen, and there was a lot of it. Today, hydrogen accounts for roughly 3/4 of all ordinary matter in the observable universe. It fills the space between stars in vast, diffuse clouds. It is the fuel that ignites inside stars and keeps them burning for billions of years. It is the most common atom in the bodies of every living thing on Earth. It is, in the most literal possible sense, the fundamental building block of everything that exists. And hydrogen has a voice. When a hydrogen atom sits in the ground state, its lowest energy configuration, The electron and the proton at its center can exist in two slightly different arrangements depending on the alignment of their quantum mechanical spins. When the electron flips from the higher energy alignment to the lower one, it releases a tiny packet of energy, a photon, a radio wave, at exactly 1420.405,751 megahertz. This transition happens spontaneously and naturally throughout the universe at all times. Every hydrogen atom in every gas cloud in every galaxy is occasionally emitting this signal. The entire cosmos is, in a quiet, continuous way, broadcasting at 1420 megahertz. It is the background hum of the universe, the frequency at which the most abundant element announces its presence to anyone with the instruments to listen. Any civilization that has developed radio astronomy, and radio astronomy is a natural step for any technological species because the sky is full of radio waves and the technology to detect them is not especially complex, would discover the hydrogen line early. It would be one of the first things they found. A bright, clean, unmistakable signal at a precise frequency, coming from everywhere in the sky simultaneously. They would map it. They would study it. They would understand it. And at some point, a mind somewhere in that civilization would ask the same question that Morrison and Cocconi asked in 1959. If we wanted to send a message to someone we have never met, in a language we have never shared, across a distance so vast that we cannot even be certain they exist, where would we start? You would start with the one thing you both already know, the hydrogen line. It is the universal reference point, the cosmic common ground. Not because anyone decided it should be, but because physics decided it, billions of years before any mind existed to make decisions. Any species advanced enough to transmit is advanced enough to know the hydrogen line. Any species advanced enough to receive is advanced enough to know the hydrogen line. It requires no agreement, no prior contact, no shared alphabet or mathematics or culture, just the knowledge that hydrogen exists, which any civilization anywhere in the universe would have. This is why the frequency of the wee-wow signal is, in many ways, the most unsettling detail of the entire story. More unsettling than the intensity. More unsettling than the perfect Gaussian profile. More unsettling even than the 45 years of silence that followed. Because the intensity could be explained by a natural source powerful enough to concentrate its energy. The Gaussian profile could theoretically be explained by a very compact and unusual radio emitter. The silence could be explained by a source that simply does not transmit continuously. But the frequency, the wow signal, appeared at 1420 megahertz, at the hydrogen line, at the one frequency in the entire radio spectrum that SETI researchers had identified before any signal was ever detected as the most logical choice for intentional interstellar communication. There are billions of frequencies a natural radio source could appear at. The radio spectrum is vast. Natural sources scatter their emissions across it in ways governed by the physics of whatever process is generating them. The probability of a natural source appearing at exactly this frequency, the one frequency that happens to correspond to the most abundant element in the universe, the one frequency that happens to have been theoretically identified as the ideal interstellar communication channel, the one frequency the big ear happened to be monitoring, that probability is not zero, but it is very small. And there is something else. The hydrogen line sits inside what radio astronomers call the water hole. This is a region of the radio spectrum, roughly from 1,420 megahertz at the lower end to 1,720 megahertz at the upper end, that is bounded by the emission frequencies of hydrogen and hydroxyl, the two components of water. Within this band, the natural background radio noise of the galaxy is at its quietest. It is a window, a gap in the cosmic noise floor where signals can travel further and be detected more cleanly than almost anywhere else in the spectrum. The name waterhole is not accidental. It is a metaphor drawn from ecology. In the African savanna, different species that would never otherwise interact are drawn to the same watering hole because water is a universal requirement. They drink beside each other. The water hole is neutral ground. Radio astronomers who named this region of the spectrum were making the same point. If civilizations separated by light years ever come to the same place to listen and transmit, the water hole is where they would gather. It is the neutral ground of the radio universe, the place where the background noise is lowest and the signal can travel furthest, and any sufficiently advanced civilization would know to look. The WOW signal was detected at the lower edge of the water hole, at the hydrogen line, at the frequency that every version of this argument, every theoretical framework for how interstellar communication would work, developed by every SETI researcher since 1959, converges on as the most logical starting point. Sit with that for a moment. Not the intensity, not the profile, not the duration, just the frequency. Something appeared at exactly the frequency that anyone searching for evidence of extraterrestrial intelligence would predict an extraterrestrial signal might use. Once. For 72 seconds. And then nothing. For 45 years and counting. There is a kind of silence that is more disturbing than noise. The silence after a sound you cannot explain. The silence of a room that felt occupied a moment ago. The silence that makes you want to look over your shoulder, not because you expect to see something, but because some part of you is not entirely sure you will not. That is the silence that has followed the WOW signal. And the closer you look at the physics of what was detected on August 15th, 1977, the harder that silence becomes to sit with comfortably. The first time they looked again, they found nothing. That was expected. A single detection is not a discovery. It is a question. Science does not accept questions as answers, and the astronomers who had seen the Waobiao signal data understood that before they could say anything meaningful about what the big ear had found, they needed to find it again, confirm it, reproduce it, hold it up to the light of repeated observation, and see if it held its shape. This is how science works. This is how it is supposed to work. One detection, no matter how compelling, no matter how precisely it matches a theoretical prediction, is not enough. You look again and again and again until either the signal reappears and you can study it properly, or the silence accumulates to the point where you are forced to conclude that whatever produced it was either fleeting, directional, or gone. They looked again within days of Ehman's discovery. The big ear returned to the coordinates where the signal had originated, a region of sky in the direction of the constellation Sagittarius, near a star cluster called Chi Sagittarii, and listened for hours, for days. The telescope swept across the same patch of sky on each rotation of the Earth, its instruments recording everything they detected at 1,420 megahertz. Nothing. The background noise of the universe, the faint hiss of hydrogen clouds scattered through the galaxy, the electromagnetic quiet of deep space, doing what deep space almost always does. Nothing that looked like 6EQUJ5. They tried again the following week, and the week after that. The big ear continued its sky survey, and whenever its rotation brought it back to the coordinates of the Douao signal, the data was examined with particular care. The same volunteers who had first reviewed the August printouts looked again at the new ones, alert for any trace of what had appeared before. Still nothing. Over the months and years that followed, the search intensified. Word of Yamt. The WOW signal spread through the SETI community, carefully, without public announcement, the way scientific communities share information they are not yet ready to defend in the open. Other telescopes were directed toward the same coordinates. Astronomers who had access to more powerful instruments, instruments more sensitive than the big ear at certain frequencies, pointed them at Chi Sagittarii and listened. Nothing. In 1987 and again in 1989, the Big Ear itself conducted dedicated follow-up observations. Extended listening sessions focused specifically on the region of sky where the signal had originated, running for longer than the standard survey sweeps, designed to maximize the chance of catching a repeat transmission if it occurred on any kind of regular schedule. The signal did not reappear. By the time the Big Ear was demolished in 1997, torn down to make way for a golf course in one of the more quietly tragic footnotes in the history of astronomy, it had spent 2 decades listening for a repeat of the most significant signal it had ever detected. It never heard it again. But the search did not end with the Big Ear. The SETI Institute, using the Very Large Array Radio Telescope in New Mexico, one of the most powerful radio observatories ever built, a collection of 27 dish antennas arranged across the desert, in a Y-shaped configuration capable of resolving radio sources with extraordinary precision, conducted its own observations of the UAO signal coordinates, multiple sessions, multiple years, the kind of dedicated, systematic observation that the big ear, with its fixed orientation and limited sensitivity, had never been able to provide. Nothing. The Allen Telescope Array in California, built specifically for SETI research and capable of monitoring millions of radio channels simultaneously, listened at the coordinates of the WOW signal across extended observation campaigns. Nothing. The Parkes Radio Telescope in Australia. The Arecibo Observatory in Puerto Rico, for decades the largest single-dish radio telescope in the world, a structure so vast it was carved into a natural limestone sinkhole in the jungle and stretched 1,000 feet across. Arecibo, which had been used to send humanity's own deliberate message into space in 1974, turned its enormous ear toward the origin point of the Wiao signal and listened with a sensitivity the big ear could never have matched. Nothing. Understand what this accumulation of silence means. It is not the silence of indifference. It is not the silence of a community that looked once and moved on. It is the silence of sustained, methodical, increasingly sophisticated observation conducted over nearly 5 decades by some of the most sensitive radio receiving instruments ever built by human beings, all of them pointed at the same patch of sky, all of them listening at the same frequency, all of them finding the same thing. Quiet. The uniform, undisturbed. Quiet of a universe that has not repeated itself. There are several ways to interpret this silence, and none of them are entirely comfortable. The first interpretation is that the signal was a one-time event, a burst, a pulse, something that happened once and was not designed to repeat, or whose repetition cycle is so long that 45 years of observation represents only a tiny fraction of the interval between transmissions. If the source transmits once every 1,000 years, or once every 10,000 years, then the probability of catching a repeat in 4.5 decades of listening is essentially zero. The silence tells us nothing about whether the signal will come again, only that it has not come yet. The second interpretation is that the signal was directional, a beam aimed specifically at a point in space, perhaps sweeping across the galaxy the way a lighthouse sweeps across the sea, not broadcasting in all directions simultaneously, but focusing its energy along a narrow corridor. If the beam has moved on, if it is now aimed somewhere else in the galaxy, then we are simply outside its path. We caught it once by the extraordinary coincidence of being in the right place at the right moment, and now it has swept past us and is illuminating some other patch of sky, some other star, some other, perhaps uninhabited, system. The third interpretation is the darkest. The signal came from a civilization that no longer exists. If the transmission was sent thousands of years ago, and given the distances involved in any interstellar scenario, thousands of years is not a long time, then whatever produced it may have been gone for centuries before the signal even reached our solar system. We may be detecting the last transmission of something that ended before human civilization had learned to write. The signal arrived. We caught one 72-second window of it, and there will be no more, not because the source is silent, but because the source is gone. This is not a fringe idea. It sits quietly at the center of what is sometimes called the Fermi paradox. The question of why, in a universe this old and this large, we have not found more evidence of intelligence. One answer is that civilizations are fragile, that they arise, flourish briefly, and end. That the galaxy is full of the electromagnetic echoes of things that no longer exist. Signals still traveling outward from their origins, carrying the voices of the dead through the silent dark, arriving at destinations their senders never knew existed. Jerry Ehman has spoken about the silence with a precision that says everything about what it means to be a scientist, sitting with a mystery you cannot resolve. He said that the failure to redetect the signal was the most frustrating aspect of the entire wow experience. Not the signal itself. The signal, whatever it was, had been detected and recorded and preserved. The frustration was the silence, the inability to go back to the universe and say, "Show me again. Prove to me what you showed me once. Let me study you properly." The universe did not oblige, and here is what makes the silence most difficult to dismiss. A signal that appears once and never repeats is exactly what you would expect if the detection were a mistake, a piece of interference, a satellite, a glitch in the equipment. Things that produce false detections tend to be irregular and unrepeatable. So the silence, paradoxically, is sometimes cited as evidence against the signal being genuine. But it is also exactly what you would expect from certain models of genuine interstellar transmission. A beam sweeping through the galaxy would not dwell on any one point. A civilization transmitting continuously in all directions would produce a signal detectable only by the most sensitive instruments at the edge of their range. A pulse sent once as a beacon, a single announcement of existence, would by definition appear only once. The silence neither confirms nor denies. It simply sits there, patient, absolute. 45 years deep and still growing. Every night that passes without a redetection adds another layer to the mystery. Not because each night makes the original signal less real. The data is what it is, and Eamon's printout has not changed, but because each night makes the question harder to answer. What spoke on August 15th, 1977? And why, in all the nights since, has it not spoken again? Science does not like unanswered questions. This is not a criticism. It is one of the most admirable qualities of the scientific enterprise, the refusal to leave a loose thread hanging, the compulsion to pull at it until either the mystery unravels into something understood or the thread proves stubborn enough to demand a better explanation. Science is, at its best, a systematic war against the unknown, and the WOOPS signal has been one of the unknown's most resilient fortifications. In the decades since Jerry Ehman circled those 6 characters, scientists have proposed, examined, tested, and debated every terrestrial and natural explanation they could construct, not lazily, not briefly, with the full weight of serious astronomical inquiry applied to the question of whether something ordinary could have produced something that looked so extraordinary. Some of those explanations were dismissed quickly. Others took years to evaluate properly. A few are still technically alive, not accepted, but not fully buried either, sustained by the absence of definitive proof rather than the presence of supporting evidence. Walk through them carefully, because the story of what the wow signal is not is, in some ways, as revealing as the story of what it might be. The first and most obvious explanation anyone reaches for when an anomalous radio signal appears is terrestrial interference. We live on a planet covered in radio transmitters, radar systems, military communications, satellites, aircraft transponders, mobile networks, research equipment. The electromagnetic environment around Earth is extraordinarily noisy. Radio telescopes are plagued by interference. It is one of the central technical challenges of radio astronomy, separating the genuine signal from the sky from the manufactured noise of human civilization. Could the WOOW signal have been a terrestrial transmitter, a military radar sweep, a satellite in an unusual orbit, a piece of equipment malfunctioning in a way that produced a spurious burst of radio energy at 1,420 megahertz? The answer, examined carefully, is almost certainly no. The frequency is the first obstacle. Broadcasting near the hydrogen line at 1,420 megahertz is internationally prohibited for exactly the reason you would expect. Radio astronomers need that frequency to be clean. It is protected spectrum. Deliberately transmitting at or near 1,420 megahertz is a violation of international radio regulations that has been in place since the 1959 radio regulations established the hydrogen line as a protected band for scientific use. This does not make a violation impossible. Regulations are broken, equipment malfunctions, military systems operate outside civilian restrictions, but it raises the bar considerably for any terrestrial interference explanation. You need not just an interfering signal, but a specifically illegal or accidental one operating at a protected frequency. The second obstacle is the Gaussian profile. Terrestrial interference does not produce clean Gaussian profiles in radio telescope data. It appears as spikes, as irregular bursts, as signals that cut in and out depending on the geometry between the transmitter and the telescope. It does not rise and fall smoothly over exactly 72 seconds. In a bell curve that precisely matches the theoretical shape of a point source rotating through a fixed telescope beam. The third obstacle is the Doppler shift. The frequency of the wow signal showed a drift consistent with a source moving relative to Earth at a velocity expected for an object in deep space. A terrestrial transmitter, even a satellite in orbit, would show a different Doppler signature. The mathematics of the frequency shift pointed away from Earth, not toward it. Taken together, these 3 characteristics make terrestrial interference an explanation that does not survive serious scrutiny. The scientists who examined it most carefully concluded that it was effectively ruled out. That left natural astronomical sources. The sky is full of radio emitters, pulsars, rotating neutron stars that sweep beams of radio energy across the galaxy like lighthouses, produce radio signals that can be intense and brief. Quasars, the enormously energetic cores of distant galaxies powered by supermassive black holes, are among the brightest radio sources in the sky. Flare stars, magnetars, interstellar masers, natural processes that concentrate radio energy in narrow beams. All of these produce detectable radio signals that observatories like the Big Ear pick up routinely. Could any of these have produced the wee-ow signal? The bandwidth problem is insurmountable. Natural astrophysical radio sources are broadband. They spread their energy across a range of frequencies. The physical processes that generate radio waves in nature, synchrotron radiation from electrons spiraling in magnetic fields, thermal emission from hot gas, the cyclotron radiation of magnetars, produce emission that covers hundreds or thousands of megahertz. Not a signal so narrow that it falls within the resolution limit of the detecting instrument. The wow-wow signal was narrow-band to a degree that has no known natural explanation. This single characteristic, the extreme narrowness of the signal's bandwidth, is what most seriously challenges every natural source hypothesis. It is the one property that most clearly distinguishes artificial transmission from natural emission. Narrowband signals are what transmitters make. They focus their energy at a precise frequency to maximize range and detectability. Nature, as far as we know, does not do this. Some researchers proposed interstellar masers as a possible source. A maser is the radio equivalent of a laser, a natural process in which a cloud of molecules is stimulated to emit radiation at a very specific frequency, producing a relatively narrow band signal. Masers exist in space. They have been detected. They are among the more unusual natural radio sources known to astronomy. But masers have characteristics that do not match the WOW signal. They are typically associated with regions of star formation or circumstellar envelopes, specific astrophysical environments that can be identified by other means. The region of sky from which the Yabuao signal originated showed no evidence of the kind of environment that produces masers. And even the narrowest known natural masers are not as narrowband as the wow signal appeared to be. The maser hypothesis was examined and found wanting. Flare stars were considered. A stellar flare can produce a brief burst of radio emission powerful enough to be detectable at interstellar distances in extreme cases. But flare stars produce broadband emission, and their radio bursts do not show the clean frequency characteristics of the WOW signal. They were ruled out. Pulsars were considered. But pulsars sweep their beams across the sky in regular, repeating pulses that recur with extraordinary clockwork precision. No pulsar produces a single 72-second detection that never repeats. The geometry and physics of pulsar emission are well understood and do not match what was observed on August 15, 1977. One by one, the conventional natural source explanations were examined. One by one, they failed to account for the full set of characteristics that made the WOW signal what it was. Not just one unusual feature, but the combination, the frequency, the bandwidth, the intensity, the profile, the Doppler shift that resisted every attempt to explain it with known physics and known sources. There remained one category of explanation that science returned to periodically, and that generated more sustained debate than any other: hydrogen clouds. The galaxy is threaded with diffuse clouds of neutral hydrogen, the raw material from which stars eventually form, floating in the space between stellar systems in vast, cold, sparse concentrations. These clouds emit radiation at 1,420 megahertz. That is the frequency of the WOW signal. Could a particularly dense or compact pocket of interstellar hydrogen have produced a signal intense enough to account for what the Big Ear recorded? The answer that most astronomers arrived at was no, for reasons that are worth understanding clearly. The intensity of the WOW signal, 30 times background noise, is far greater than what any known hydrogen cloud produces. Interstellar hydrogen clouds are diffuse and cold. They emit weakly. The emission you detect from them is measured in fractions of degrees of antenna temperature, not in multiples of the background noise floor. To reach the intensity of the WOW signal from a natural hydrogen source would require a concentration and temperature of hydrogen that has no precedent in any known astronomical observation. Furthermore, hydrogen clouds do not produce narrowband signals. Their emission is thermally broadened, spread across a range of frequencies by the random thermal motion of the hydrogen atoms. The WOW signal's extreme narrowness is precisely the opposite of what thermal emission from a gas cloud looks like. The hydrogen cloud hypothesis did not hold up. Each explanation followed the same trajectory: initial proposal, serious examination, discovery of one or more fundamental incompatibilities with the observed signal characteristics, quiet withdrawal. By the end of 2 decades of analysis, the scientific community had arrived at a position that was uncomfortable in a way that science rarely tolerates for long. They had ruled out or seriously challenged every natural and terrestrial explanation they could construct. They had not detected the signal again, and they had not proposed any explanation, natural, artificial, or otherwise, that fully accounted for every characteristic of what the Big Ear recorded. The WOW signal sat in the middle of this landscape of eliminated possibilities, like something that should not be there. Not confirmed as extraterrestrial, not explained as natural, occupying an increasingly narrow space between what science could account for and what it could not. And then, in 2017, a new explanation arrived. One that briefly looked promising, one that divided the SETI community more sharply than anything since the original detection, and one that, on closer examination, raised as many questions as it answered. In the summer of 2017, exactly 40 years after Jerry Ehman sat down with his red pen and a stack of computer printouts, an astronomer named Antonio Paris published a paper that claimed to have solved the mystery. Paris was not a career SETI researcher. He was an astronomer at St. Petersburg College in Florida, and his background was in planetary science rather than the search for extraterrestrial intelligence. He had come to the WOW signal from a different direction than most of the people who had spent years examining it, without the accumulated assumptions of the SETI community, but also without the accumulated knowledge of everyone who had looked before him. His proposal was this: 2 comets, designated 266/P, Christensen, and P/2008Y to Encke, had been in the vicinity of the coordinates from which the WOW signal appeared to have originated on the night of August 15th, 1977. These comets had not been discovered at the time of the original detection. They were found years later, and their historical positions could be calculated by working backward through orbital mechanics. Paris argued that these two comets, passing through the Big Ear's field of view on that night, could have been the source of the signal. The mechanism he proposed was straightforward. Comets are not simply rocks. They are dirty snowballs, mixtures of ice, dust, and organic compounds that, when they approach the sun, begin to sublimate. The ices on their surfaces vaporize and release clouds of gas that surround the nucleus in what is called a coma. This coma can extend tens of thousands of kilometers from the comet's center. Water ice, when it sublimates, releases hydrogen and hydroxyl, the two components of water. Free hydrogen in a cometary coma can emit radiation at 1,420 megahertz. This is a known phenomenon. Hydrogen emission from comets has been detected before. Paris argued that the hydrogen coma of one or both of these comets passing through the narrow beam of the Big Ear at exactly the right moment could have produced a signal intense enough to account for what was recorded. The paper attracted immediate and intense attention. For a brief period, it seemed like it might be the answer. A clean, natural, testable explanation that required no exotic physics and no appeal to extraterrestrial intelligence. The kind of explanation that science prefers: simple, familiar, grounded in known processes. The media embraced it enthusiastically. Headlines declared the UAU signal mystery solved. 40 years of uncertainty wrapped up in a press release. The story had a satisfying arc, the long-standing puzzle finally yielding to patient science, the exotic explanation replaced by the mundane. The SETI community was considerably less enthusiastic. The objections came quickly, and they came from people who had spent careers thinking about the WOW signal and about radio astronomy more broadly. They were not objections born of defensiveness or reluctance to accept a natural explanation. They were technical, specific, and difficult to dismiss. The first and most fundamental objection was about intensity. Cometary hydrogen emission at 1,420 megahertz is weak, detectably weak in some cases when sensitive modern instruments are pointed at nearby comets under favorable conditions. But the WOW signal was not weak. It was 30 times above the background noise floor of the Big Ear, an extraordinary intensity for any source, natural or artificial. The hydrogen emission from a cometary coma at the distance of any comet that would be passing through the inner solar system is not remotely close to producing that kind of signal strength. To put it in concrete terms, the hydrogen emission from a cometary coma that would be detectable by a sensitive modern instrument pointed directly at a nearby comet. With dedicated observation time, is orders of magnitude fainter than what the WOW signal registered on a telescope that was not even designed for cometary observation and was simply sweeping the sky as part of a routine survey. The numbers did not work. The second objection was about bandwidth. Cometary hydrogen emission is not narrowband. The hydrogen atoms in a cometary coma are moving at different velocities in different directions, some toward the telescope, some away from it, some sideways. This random motion broadens the emission line through the Doppler effect in exactly the way that any thermally distributed population of atoms would. The emission from a cometary coma covers a range of frequencies, not the extreme narrowband signal that the WIAO detection implied. This was the same objection that had defeated the interstellar hydrogen cloud hypothesis years earlier. Diffuse natural hydrogen emission is broad. The WOW signal was narrow. The physics of cometary emission does not produce the kind of signal that was detected. The third objection was about the Gaussian profile. A comet moves. It moves through the sky at a rate determined by its orbital velocity, faster than the stars and far faster than the distant extragalactic sources that the Big Ear was designed to observe. If a comet had passed through the Big Ear's beam on August 15, 1977, it would not have produced a clean Gaussian profile. It would have moved through the beam at its own rate, independent of Earth's rotation, producing a distorted signal shape that would look different from the perfect bell curve that was recorded. The WOW signal's Gaussian profile matched a fixed point in space, something that was not moving relative to the stars. A comet, by definition, is not a fixed point in space. Paris responded to some of these objections. He argued that the intensity discrepancy could be explained by unusually dense concentrations of hydrogen in the cometary coma. He suggested that the bandwidth and profile objections were less decisive than his critics claimed. The back and forth continued through papers and conference presentations and public statements, and what emerged was not a resolution, but a deepening of the disagreement. Then came the practical test. In November 2016, before the paper was even published, Paris and colleagues had pointed a telescope at Comet 266/P Christensen, one of the two comets he identified as the likely source, and observed it at 1,420 megahertz as it passed through a similar region of sky. They reported detecting a signal. This was presented as confirmation. The comet emitted at the hydrogen line. Therefore, comets could produce WOW-like signals. Therefore, the WOW signal was probably cometary in origin. The SETI community looked at the reported detection carefully. What Paris had measured was hydrogen emission from the comet's coma. Detectable, real, genuine cometary hydrogen emission. But the intensity of what he detected was dramatically, fundamentally lower than the WOW signal. Not slightly lower, not within an order of magnitude. The signal he detected from 266/P Christensen was so much fainter than the WOW signal that bridging the gap between them required invoking conditions for which there was no observational evidence. A cometary coma of extraordinary density unlike anything previously observed, at a distance and geometry that happened to produce exactly the right signal strength at exactly the right frequency with exactly the right profile. The more closely the SETI community examined the comet hypothesis, the more it looked like a hypothesis shaped around a conclusion rather than a conclusion derived from evidence. But here is where it becomes complicated. The comet hypothesis was not proven wrong in the clean, decisive way that some of the earlier explanations had been. It was challenged, seriously and persistently challenged, with objections that most radio astronomers found compelling. But Paris maintained his position. His paper remained in the literature. The debate continued, and this ambiguity, this inability, To definitively prove or disprove even the most seriously challenged explanation is itself part of the WOW signal story. Science progresses by falsification. A hypothesis is tested until it breaks. But the WOW signal was a single event that lasted 72 seconds and has never been repeated. It cannot be re-examined under controlled conditions. It cannot be reproduced. The data that exists is the data that was collected on one night by one instrument using one configuration of settings that no longer exists. You cannot run the experiment again. This is the methodological prison in which every attempt to explain the WOW signal finds itself. The evidence is fixed and finite. The signal cannot be summoned for closer inspection. Every hypothesis must be evaluated against a dataset that will never grow larger. Jerry Ehman himself responded to the comet hypothesis with the measured precision that characterized everything he said about the signal. He examined Paris's arguments carefully and found them unconvincing. The intensity discrepancy troubled him most. A cometary coma producing a signal 30 times above the Big Ear's noise floor was, in his assessment, physically implausible given what was known about cometary hydrogen emission. He did not say this with drama. He said it the way a scientist says something, with specificity and evidence, and the quiet authority of someone who has spent more time thinking about this particular question than almost anyone else alive. The comet hypothesis did not solve the mystery. It added a new chapter to it, and it illustrated something important about the WOW signal that is easy to miss when you are focused on the physics and the numbers and the competing hypotheses. The mystery is not just about what the signal was. It is about what it reveals concerning the limits of what science can do when the evidence is irreducibly singular. When there is only one data point, and it will not repeat, and the instrument that collected it no longer exists, and the night it came from is 45 years gone. In those conditions, explanation becomes extraordinarily difficult. Not because the answer does not exist, but because the universe, on this particular question, has so far declined to give us enough evidence to find it. Set aside the explanations for a moment. Set aside the comets and the hydrogen clouds and the bandwidth calculations and the Gaussian profiles. Set aside the papers and the counterpapers and the conference debates and the carefully worded academic disagreements. Set all of that down for a moment and ask the question that sits underneath all of it. The question that everyone who has ever seriously engaged with the WOW signal eventually finds themselves confronting in the quiet of their own thinking. What if it was real? Not real in the sense of being a genuine detection. It was unquestionably a genuine detection. The data is not in dispute. Real in the deeper sense. Real in the sense that matters most. What if the signal that appeared in the Big Ear's data on August 15, 1977, was what its characteristics most naturally suggest it was? A transmission. An intentional, directed, artificial signal. Something produced not by physics, but by intention. Not by nature, but by mind. What would that mean? This is not a question science handles comfortably. Science is built for the empirical, for things that can be measured, repeated, falsified, and tested. The implications of a confirmed extraterrestrial signal extend well beyond the empirical into territory that science can gesture toward, but cannot fully map. Philosophy, theology, the entire edifice of human self-understanding. The story we tell ourselves about what we are and where we fit in the universe. But start with the science. Start with what the physics of the signal would require if it were genuinely artificial. The signal came from the direction of the constellation Sagittarius, more specifically, from a region of sky near the star cluster Chi Sagittarii. The stars in that region lie at distances ranging from roughly 200 to 400 light years from Earth. If the signal originated from a civilization orbiting one of those stars, then the transmission left its source somewhere between 200 and 400 years before it arrived at the Big Ear. It was sent, at the earliest, during the 17th century, when Galileo was still alive, when Isaac Newton was a child, when humanity had not yet conceived of radio waves, let alone built instruments to detect them. Whatever sent it did not know we would be listening, could not have known. The signal was sent into a universe in which Earth, as far as any outside observer could tell, showed no sign of technological civilization. Unless they were patient, unless they had been transmitting for a long time, in many directions, with a patience that no human institution has ever managed to sustain. Broadcasting into the dark, on the assumption that eventually, somewhere, something would develop the ability to hear. The power required to produce a signal detectable at that distance, 30 times above background noise in a telescope that was not even aimed at the source, but simply sweeping past it in the course of a routine survey, is worth considering carefully. The Big Ear was not a sensitive instrument by modern standards. It was a flat reflector with limited gain. For a signal to appear at the intensity the WOW data recorded, from a source hundreds of light years away, the transmitter would need to be radiating at a power level that dwarfs anything human civilization has ever produced. We have sent radio signals into space, the most powerful, deliberate transmission humanity has ever broadcast. The Arecibo message of 1974 used a transmitter radiating at roughly 450 kilowatts focused into a narrow beam. It was aimed at a star cluster 25,000 light years away. By the time it reaches its target, millennia from now, it will be so faint as to be essentially undetectable, except by an instrument orders of magnitude more sensitive than anything we currently possess. The power implied by the WOW signal, if its source were hundreds of light years distant, would require a transmitter capable of radiating at levels that our current understanding of physics and engineering places in the category of what theorists call a Kardashev Type II civilization, a civilization that has learned to harness energy at the scale of an entire star, not a civilization somewhat more advanced than ours, not a civilization a few centuries ahead of us, a civilization so far beyond our current level of development that the comparison strains language. We are, by Kardashev's framework, barely a Type I civilization, a species that has not yet fully mastered the energy resources of a single planet. The gap between where we are and where a Type II civilization would be is not a gap measured in centuries. It is a gap measured in the kind of time that makes centuries look like moments. If the WOW signal was real, something exists in our galactic neighborhood that has had that much more time than us. that has solved problems we have not yet learned to ask, that has built things on scales we cannot currently imagine, that has survived. And this is the detail that carries the most weight, long enough to reach that level of development. Because survival is not guaranteed. This is the part of the conversation that tends to get lost in the excitement of imagining a more advanced civilization. The question is not just whether intelligence can develop, it is whether intelligence can persist, whether a species that develops the capacity for technology also develops the wisdom to keep itself alive long enough to use that technology across the timescales required to build a stellar civilization. We do not have a confident answer to that question about ourselves, let alone about others. But if the wow signal was genuine, if something out there in the direction of Sagittarius was powerful enough and old enough and stable enough to be broadcasting at stellar energy scales, then at least one answer, in at least one case, appears to be yes. Intelligence can survive. Intelligence can persist. Intelligence can reach scales of power and duration that place it in a different category of existence from anything we have known. That thought is not comfortable in a simple way. It is not merely reassuring or merely terrifying. It is both simultaneously in a proportion that shifts depending on the question you ask next. Because if something like that exists and has been transmitting, and we caught 72 seconds of its signal and never heard it again, then what does that silence say? One possibility is benign. The signal was not aimed at us specifically. It was a general broadcast, a beacon sent in many directions, perhaps cycling through targets on a schedule measured in years or decades or centuries. We happened to be listening during the 72 seconds that the beam swept past Earth. The next sweep may come in 100 years or 1,000. On a cosmic time scale, the silence since 1977 is nothing. A breath between words. Another possibility is more unsettling. They know we exist. They detected us. Our own radio leakage has been radiating into space since the early 20th century, and a sufficiently sensitive instrument at the right distance would have been able to detect it for decades before 1977. They sent a signal. We heard it. We sent nothing back in the 72 seconds we had. The beam moved on, and now we are simply waiting in a silence of our own making. The silence of a species that received a message and did not know, in the moment, that it was a message at all. There is a third possibility that almost nobody discusses because it sits in territory that even the most open-minded scientists find uncomfortable. The signal was not a beacon. It was not a general broadcast cycling through the galaxy on a patient schedule. It was aimed, deliberately aimed at this solar system, at this specific moment in our development, knowing or anticipating that we would have just enough technology to detect it, but not enough to respond immediately. Test. An introduction. An opening move in a conversation that requires us to take the next step. If that is true, then the silence since 1977 is not the universe's silence. It is ours. We heard something. We were not sure what it was. We looked for it again and could not find it. And we have spent 45 years arguing about comets. Jerry Ehman has sat with these implications for nearly half a century. He is a careful man, a scientist who built his reputation on precision and measured language and the refusal to claim more than the evidence supports. He does not say the WOW signal was extraterrestrial. He says he does not know what it was. But he also does not pretend the implications of the extraterrestrial hypothesis are small. He said once that if the signal was artificial, then it would be the most important discovery in the history of our species. Not one of the most important. The most important. More significant than fire, than writing, than the wheel, than every scientific revolution from Copernicus to Einstein. Because fire changed what humans could do. Writing changed how humans could communicate. Science changed how humans could understand the world around them. But confirmation that we are not alone would change what humans are. It would rewrite the story of life itself. Not the story of one species on one planet, but the story of intelligence as a phenomenon in the universe. Whether it is rare or common, whether it is fragile or durable, whether the cosmos is, at some level, alive with mind, or whether we are an accident, isolated and improbable, in a universe that produced us once and will not do so again. That question is not abstract. It is the deepest question we have. And for 72 seconds on a warm August night in 1977, something may have answered it. We were not paying close enough attention to hear the answer clearly, and the universe, as yet, has not chosen to repeat itself. 35 years of silence. That was how long it had been when someone finally decided to write back. Not a government, not a space agency, not a consortium of the world's leading astronomers gathered in a conference room, weighing the diplomatic implications of humanity's first response to a possible extraterrestrial signal. Not the kind of carefully coordinated, internationally sanctioned, scientifically rigorous response that the protocols drawn up by the SETI community over decades had envisioned. A social media campaign. In August 2012, to mark the 35th anniversary of the WEO signal, a project called Chasing UFOs, later known as the National Geographic Channel in collaboration with a team of researchers, coordinated the transmission of a response toward the coordinates from which the WOW signal had appeared to originate. The transmission was made using a powerful radar telescope at a facility in Ukraine, and the content of the message was drawn from submissions made by members of the public through Twitter. 10,000 tweets collected from people around the world who wanted to say something, anything, into the dark in the direction of whatever might have spoken in 1977. Personal messages, greetings, questions, declarations of existence. The full chaotic spectrum of what human beings choose to say when given the opportunity to speak to the unknown. They were encoded into a radio signal and beamed toward Chi Sagittarii. The response to this project within the scientific community was divided in a way that revealed something important about how deeply the WOW signal had unsettled the normal protocols of astronomical research. Some researchers welcomed it. The gesture, even if scientifically imprecise, represented something genuine. A species acknowledging that it had heard something, that it was aware, that it was trying to respond. If there was anything out there that had sent the original signal, this was at least an indication that the message had been received by a civilization that was developing, that was curious, that was reaching back. Others were considerably more cautious. The question of whether humanity should respond to possible extraterrestrial signals, or whether we should be transmitting into space at all, is one of the most genuinely contested debates in the SETI community. Not contested in the polite, academic way that scientists debate the finer points of data interpretation. Contested in a way that touches on the deepest uncertainties about what contact with another civilization might actually mean for our survival. Stephen Hawking, in the years before his death, was among the most prominent voices arguing for caution. His position was stark, and it was simple. We do not know the intentions of any civilization advanced enough to be transmitting across interstellar distances. A civilization capable of sending a signal detectable hundreds of light years away is a civilization operating at energy scales we cannot match. If their intentions toward us are anything other than benign, or even if they are simply indifferent to our existence in the way that we are often indifferent to the existence of smaller organisms, then announcing our presence to them is an act whose consequences we cannot control and may not survive. He drew an analogy that made people uncomfortable because it was difficult to argue with. When Columbus arrived in the Americas, the meeting did not go well for the people who were already there. The disparity in technology between the arriving civilization and the existing one determined the outcome in ways that the existing civilization had no power to influence. Hawking argued that advertising our existence to any civilization capable of interstellar travel or interstellar communication was the equivalent of the indigenous peoples of the Americas sending a signal to Europe saying, "Here we are, come find us." This argument is not universally accepted. Others in the SETI community push back on it with equal force. They argue that a civilization advanced enough to travel between stars would have long since moved past the kind of resource acquisition imperialism that characterized human colonial expansion. That the energy required to travel between stars is so vast that no civilization would expend it for conquest when simpler methods of obtaining resources exist. That the very fact of surviving long enough to reach interstellar capability implies a level of social and philosophical development incompatible with aggression toward primitive species. Both sides of this argument make points that are difficult to refute with evidence because we have, as yet, no evidence of any other civilization to examine. We are arguing about the psychology of minds we have never encountered, operating under assumptions derived entirely from our own limited experience of what intelligence looks like. The 2012 transmission happened anyway. And the mathematical reality of interstellar communication means that the question of whether it was wise will not be answered quickly. If the source of the wow-wow signal is at the lower end of the estimated distance range, roughly 200 light-years away, then the 2012 transmission will not arrive for another 165 years or so, accounting for the 35 years that have already elapsed. Any response to that transmission would then take another 200 years to reach us. The earliest we could possibly receive a reply to humanity's 2012 message is somewhere around the year 2038. Nobody alive today will know whether it worked. This is one of the most quietly disorienting aspects of the entire wow-wow signal story. The timescales involved in interstellar communication reduce human lifetimes to irrelevance. The conversation, if it exists, operates on scales that no individual human being can witness from beginning to end. The person who sends the message and the person who receives The reply will be separated by centuries. The continuity required to sustain that kind of exchange, the institutional memory, the civilizational patience, the commitment to a project whose payoff may come 300 years after the investment, is something human civilization has never demonstrated. We have trouble sustaining commitments across decades. We have trouble maintaining scientific programs across administrations and funding cycles. The idea of a species that makes a transmission in 2012 and waits in organized, patient, prepared readiness for a reply that might come in 2038 is not an accurate description of how human civilization currently works. But perhaps that is part of what the Wow signal is asking of us. Not just the scientific question of what it was, but the civilizational question of what kind of species we need to become in order to properly participate in a universe that may communicate on timescales we are not yet patient enough to accommodate. The 2012 transmission was imperfect. It was improvised and uncoordinated and scientifically somewhat naive. It sent 10,000 tweets into the direction of a possible alien signal, which is perhaps not the most carefully considered opening gambit in the history of interstellar diplomacy. But it was something. It was a species acknowledging, even imperfectly, that it had heard something on a night in August 1977 and had not forgotten. That it was still thinking about those 72 seconds. That it wanted to reach back across the silence and say, "We were here. We are still here. We heard you, or we heard something, and we have not stopped wondering what it was." There is a Voyager probe currently traveling through interstellar space. The same Voyager 1 that Jerry Ehman's contemporaries launched in the same year the Wow signal was detected, 1977. It carries a golden record. Images and sounds and music and greetings in dozens of languages. A physical message sent into the dark on the assumption that someone, somewhere, might eventually find it. The people who made that record understood something that the debate about the 2012 Twitter transmission sometimes loses. The act of reaching out is not purely strategic. It is not purely a calculation of risk and reward. It is also an expression of what a species believes about itself and about the universe it inhabits. A species that refuses to reach out, that retreats into silence out of fear of what might hear it, has made a choice about its own nature. It has decided that the universe is primarily a threat, that intelligence, wherever it exists, is more likely to be dangerous than not, that the appropriate response to the possibility of others is concealment. A species that reaches out, imperfectly, in 140-character fragments through a radar telescope in Ukraine, has made a different choice. It has decided that the universe is worth speaking to, that whatever might hear it is worth the risk of being heard, that the story of intelligence in the cosmos is, at least potentially, a story of connection rather than isolation. Whether that choice was wise will not be known in our lifetimes. What is known is that on a night in 1977, something may have made the same choice before we did. Something may have decided that the universe was worth speaking into, that somewhere in the dark there might be a mind capable of listening, and that the act of transmission was worth the patience required to wait for a response that might never come. It transmitted for 72 seconds. We listened. And then For 35 years, we were quiet. Before finally saying, imperfectly but sincerely, in the language of the early 21st century, we heard you. It looks like you accidentally pasted Section 9 back into the chat. No problem. Here is Section 10, the final section. There is a question that never fully leaves you once you have spent enough time with the wow signal. Not the technical question, not the question of comets or hydrogen clouds or Gaussian profiles or bandwidth. Those questions are important, and they deserve the serious attention they have received. But underneath all of them, persistent and quiet and impossible to fully silence, is a simpler question. Are we alone? It is the oldest question intelligence has ever asked about itself. It predates science. It predates philosophy. It predates writing. The moment any mind became self-aware enough to look up at the night sky and register the scale of what it was seeing, the vastness, the depth, the sheer incomprehensible number of lights spread across the dark. That question arose, spontaneously, inevitably, as naturally as breathing. Are we the only ones doing this? For most of human history, the question had no empirical purchase. It was metaphysical, religious, a matter of belief rather than investigation. The universe was what it appeared to be from the surface of one small planet, a backdrop, beautiful and permanent, existing for reasons that theology addressed and science had not yet developed the tools to examine. Then came the tools: radio telescopes, spectral analysis, the mathematics of orbital mechanics and stellar evolution, the slow, accumulating understanding of how stars form and how planets coalesce from the debris of those formations, and how chemistry moves under the right conditions toward complexity. The realization that the building blocks of life, carbon, hydrogen, oxygen, nitrogen, the organic molecules from which living things are constructed, are not rare. They are common. They are found in interstellar gas clouds, in meteorites, in the atmospheres of planets across the solar system. The universe is, chemically speaking, predisposed toward the ingredients of life. Whether it is predisposed toward life itself is a different question, and whether it is predisposed toward the particular kind of complex, self-aware, technologically capable life that builds radio telescopes and asks questions about the cosmos is a different question still. But the tools are here now, and they have been used. And in 45 years of systematic, dedicated, increasingly sophisticated searching, they have found one candidate, one signal, one 72-second window of data from a summer night in Ohio that has resisted every attempt at a clean, natural explanation and has never repeated itself. 1. The next generation of radio telescopes will be unlike anything that existed when Jerry Ehman sat down with that printout. The Square Kilometer Array, a telescope being constructed across sites in South Africa and Australia, consisting of thousands of individual antenna elements spread across vast distances and linked together into a single instrument of extraordinary sensitivity, will be capable of detecting signals far fainter than anything the big ear could have registered. It will be able to monitor millions of frequency channels simultaneously across large swaths of sky. It will be, when it reaches full operation, the most powerful radio observatory in human history by a significant margin. If something in our galactic neighborhood is transmitting at the power level implied by the wow signal, the square kilometer array will hear it. Not might hear it, will hear it. The sensitivity of the instrument makes that close to a certainty, assuming the signal continues or repeats. There are other searches underway. Breakthrough. Listen, funded by Russian entrepreneur Yuri Milner and endorsed by Stephen Hawking before his death, is the most comprehensive SETI program ever conducted. It uses some of the most sensitive radio telescopes in the world to observe the nearest million stars across a wide range of frequencies. It generates more data in a single day than all previous SETI programs combined generated in their entire histories. It has not found the wow signal. It has not yet found anything that conclusively resembles it. But the search is young, and the universe is old. And patience, as the entire wow signal story illustrates, is the fundamental currency of this particular inquiry. What would it mean if the square kilometer array, or breakthrough listen, or some future instrument we have not yet conceived, detected a repeat of the wow signal? The protocols exist. They have been drawn up carefully by the SETI community over decades, precisely because the question of what to do upon receiving a confirmed extraterrestrial signal is not one you want to answer in the confusion of the moment. The first step is verification, independent confirmation by multiple telescopes that the signal is real and is not terrestrial interference. The second step is notification. Scientific institutions, governments, the United Nations. The third step is public announcement, with all the care and preparation that an announcement of that magnitude would require. What happens after that is beyond any protocol. It is beyond any planning. It is the moment that human civilization crosses a threshold it has been approaching since the first human being looked up at the night sky and felt the weight of the question pressing down. Not alone. Two words that would change everything. Not immediately, not with physical consequence in the short term. The nearest possible source of the Wu-Ow signal is still hundreds of light years away, unreachable by any technology we currently possess or could possess within any foreseeable timescale. The confirmation would not bring visitors. It would not bring danger, at least not immediately. It would not change the daily mechanics of life on Earth. But it would change what daily life on Earth means. It would mean that the story of intelligence is not a story about one species on one planet, in one solar system, on the outer arm of one galaxy among 2 trillion. It is a story about something the universe does, something the universe is capable of producing in more than one place, more than one time, more than one form. It would mean that the silence of the cosmos is not the silence of emptiness. It is the silence of distance, the silence of timescales too long for individual human lives to bridge. The silence of a universe in which minds are separated by light years and centuries, but are not fundamentally alone. And it would mean that Jerry Ehman's red pen circle, that small, unremarkable gesture of a careful man noting something unusual in a column of data, was the moment a species first heard the universe speaking back to it. We are not there yet. The wow signal remains what it has always been, a question without a definitive answer. A 72-second window of data from August 15th, 1977, that no subsequent observation has explained, and no subsequent observation has repeated. A single entry in the long record of things humanity has encountered and not yet understood. But here is what 45 years of failing to explain it has produced. Not certainty, not proof, not the clean resolution that science prefers and rarely delivers on questions this deep. It has produced humility, the humility of confronting something that resists your best explanations, the humility of sitting with a question that your most powerful instruments and your most careful minds have not yet answered. The humility of acknowledging that the universe is under no obligation to be simple or legible or to repeat itself for your convenience. That humility is not a small thing. It is, in fact, the beginning of wisdom, the recognition that what we know is bounded, that beyond the boundary there are things we do not understand, that some of those things may be more important than anything we do. Understand. The wow signal sits at that boundary. On one side, everything we know, physics, radio astronomy, the catalog of natural sources, the mathematics of signal propagation, the history of SETI research, the accumulated careful work of hundreds of scientists across 5 decades. On the other side, 72 seconds of data that none of it fully explains. Every night, the radio telescopes continue their work. The square-kilometer array rises from the South African desert and the Australian outback, antenna by antenna, slowly assembling itself into the most powerful listening instrument our species has ever built. Breakthrough. Listen processes its petabytes of data, its algorithms scanning for patterns in the noise. The next generation of SETI researchers sits with the same question that motivated Frank Drake in 1960 and Jerry Ehman in 1977. Are we alone? And somewhere in the direction of the constellation Sagittarius, at a distance of somewhere between 200 and 400 light years, whatever produced those 6 characters on a summer night in Ohio is either still there or it is not, is either still transmitting or it is not, is either waiting for a response or it has moved on or it has ended or it never existed in the form we imagine. We do not know. We are still listening. And that, the fact that we are still listening, after everything, after 45 years of silence and frustrated follow-up and academic debate and failed explanations, that tells you something about what kind of creature the human being is. Not a creature that gives up on the question just because the answer is slow in coming. Not a creature that looks at a mystery and decides, for the sake of comfort, that there is nothing there. A creature that sits with the unknown, that keeps the instruments running, that trains the next generation of listeners and hands them the question intact and says, "We heard something once. We do not know what it was. Keep listening." That is who we are. And the universe, vast, ancient, mostly silent, occasionally surprising, is still out there, still full of signals we have not yet learned to hear. If this changed the way you see the silence between the stars, the cosmic depth has more waiting for you. Subscribe, and I will see you in the next one.